1. Did a meteor impact trigger a massive Grand Canyon landslide 56,000 years ago? 2. Link between Grand Canyon landslide and meteor crater impact unveiled. 3. Did a meteor impact trigger a massive landslide in the Grand Canyon? Scientific investigation. 1. Did a meteor impact trigger a massive Grand Canyon landslide 56,000 years ago? Could a meteor impact have been the catalyst for a colossal landslide in the Grand Canyon over 56,000 years ago? This intriguing possibility suggests that a meteorite collision might have dramatically altered the landscape of this iconic national park and the Colorado River that flows through it. Geologists have been investigating driftwood and sediment samples found in Stanton's Cave, located in Marble Canyon, which is situated in the eastern section of the Grand Canyon. Their research indicates a potential link between this area and the renowned Meteor crater, also known as Barringer Crater, found in northern Arizona. This connection raises fascinating questions about the geological history of the region. Through careful excavation and extensive radiocarbon dating, scientists have established that the driftwood discovered in the cave dates back approximately 56,000 years. Interestingly, the entrance to Stanton's Cave is currently positioned 150 feet, 46 meters, above the Colorado River. A recent study proposes that this driftwood was transported there by an ancient paleolake, which formed as a result of a massive landslide that blocked the river's flow. Carl Karlstrom, a co-lead author of the study and a professor of Earth and Planetary Sciences at the University of New Mexico, stated it would have required a flood level 10 times greater than any flood recorded in the last several thousand years. This assertion highlights the scale of the event that may have occurred. The research posits that the meteor strike responsible for creating Meteor crater could be associated with the formation of a paleolake in the Grand Canyon at the same time. The impact would have generated an earthquake with a magnitude between 5.4 and 6, producing shock waves strong enough to destabilize cliffs located 100 miles (161 kilometers) away, potentially triggering a massive landslide. This landslide could have deposited enough debris to dam the Colorado River, leading to the creation of a lake. Further investigations have been conducted in other caves situated high above the river to uncover more about the canyon's geological history. In addition to the driftwood, researchers have discovered ancient beaver tracks in locations that are now inaccessible to these aquatic animals, lending further credence to the theory that a paleolake once existed in this area. The researchers estimate that the paleolake, based on driftwood and sediment samples found in caves as high as 3,084 feet (940 meters), would have stretched approximately 50 miles (80 kilometers) in length and reached depths of nearly 300 feet (91 meters). Over time, the dam that obstructed the Colorado River may have been overtopped and eroded, eventually becoming filled with sediment. While the evidence linking the paleolake, the meteorite impact, and the resulting landslide is compelling, the researchers caution that additional studies are necessary to rule out other potential explanations for the river damming, such as random rockfalls or local earthquakes occurring around the same period. The findings of this study were published on July 15 in the journal Geology, contributing to our understanding of the complex geological processes that have shaped the Grand Canyon over millennia. If you're fascinated by space and geology, join our space forums to continue the conversation about the latest missions, night sky events, and more. We welcome your thoughts, news tips, or comments at community@space.com. Samantha Matthewson, who began her journey with space.com as an intern in the summer of 2016, holds a BA in journalism and environmental science from the University of New Haven in Connecticut. Her previous work has appeared in Nature World News. When she's not immersed in writing or exploring scientific topics, Samantha enjoys traveling and capturing moments through photography. You can follow her on Twitter at Sam_Ashley13. 2. Link between Grand Canyon landslide and Meteor crater impact unveiled. The connection between the Grand Canyon landslide and the Meteor crater impact is a fascinating chapter in the story of our planet's geological history. A recent study published in the journal Geology by distinguished professors emeritus Carl Karlstrom and Laurie Crossie from the University of New Mexico, along with their collaborators, reveals an intriguing relationship between two of the American Southwest's most iconic geological features, the Grand Canyon and the Meteor crater. Titled Grand Canyon Landslide Dam and Paleolake Triggered by the Meteor Crater Impact at 56 Ka, this article uncovers a remarkable coincidence in the geological timelines of a meteor impact and a landslide dam that obstructed the Colorado River, leading to the formation of a paleolake in the Grand Canyon approximately 56,000 years ago. This finding not only sheds light on the events of the past but also highlights the collaborative efforts of multiple generations of scientists and advancements in scientific methodologies. Karlstrom noted it would have required a flood level 10 times greater than any recorded in the last several thousand years. Alternatively, these could be ancient deposits left behind as the river eroded the landscape, or they might have drifted in from a paleolake created by a downstream lava or landslide dam. We needed to determine the age of the cave deposits to understand this better. In the mid-1960s, Karlstrom's father, Thor, was involved in a cross-disciplinary geology and archaeology project in the cave, where they discovered remnants of species that have since vanished from the Grand Canyon, such as the California condor and Harrington's mountain goat. They also unearthed split-twig figurines crafted by the ancestors of local tribes, dating back 3,000 to 4,000 years. Initially, the driftwood was dated to be over 35,000 years old, which was near the upper limit of the radiocarbon dating technique available at that time. This age was later recalibrated in 1984 to 43,500 years. However, the new study, utilizing advanced methods and analyses from laboratories in New Zealand and Australia, now reports an age of 56,000 years. The research team included Chris Baston, who fortuitously was examining the driftwood collections at the University of Arizona's Tree Ring Laboratory, and David Kring, the science coordinator for Meteor Crater, who had been working on recalibrating the ages of the crater, which were estimated to be between 53,000 and 63,000 years old using various methods. During a road trip to the US, co-author Jonathan Palmer from the Australian lab visited both the Meteor Crater and Baston at the UA lab, where he noted the remarkable coincidence in the ages that inspired this paper. Crossy remarked, "From our extensive research trips, Carl and I were aware of other easily accessible caves that contained both driftwood and sediment suitable for dating." They sent additional driftwood samples to the labs in Australia and New Zealand, along with sediment samples to Tammy Rittner at Utah State University. The use of two dating methods proved crucial to this study, with both returning statistically similar ages of 55,600 years. In the 1980s, Richard Hereford from the USGS in Flagstaff suggested that a rockslide near Nankowit Canyon, located about 22 river miles downstream from Stanton's Cave, could have created a dam and a paleolake that allowed driftwood to enter Stanton's Cave. This hypothesis gained renewed attention with the discovery of additional 56,000-year-old samples from various caves situated high above the river. Notably, Grand Canyon Cave adjacent Bolensky observed beaver tracks in Vaz's Paradise Caves, an area that would be inaccessible to beavers. The combined findings regarding the depth and extent of the paleolake are illustrated in the Colorado River Profile Graph. The key findings from the geology paper include: 1. Driftwood and sediment have been discovered in numerous caves at elevations reaching 940 meters, indicating that the lake must have backed up water above Lee's Ferry, where boating excursions commence. Thus, the paleolake hypothesis appears to be a holding water. 2. In two locations, the reddish chaotic material from the dam at Nankowit Canyon is covered by rounded, well-traveled river cobbles, suggesting that a dam existed there that was overtopped and eroded significantly, likely within 1,000 years, based on comparisons to modern concrete dams that accumulate sediment. But was the impact of the Meteor Crater sufficient to trigger such a landslide? Kring has explored the physics behind this phenomenon and calculated that the impact would have generated a magnitude 5.4 earthquake, or even M6 under different assumptions, with the shock wave still registering around M3.5 after traveling the 100-mile distance to the Grand Canyon. This means that the impact could have shaken loose the steep cliffs of the Grand Canyon, which were already primed for collapse, as evidenced by the numerous rockfalls that occur in the area. Karlstrom explained, "The team has presented these arguments without claiming to have definitive proof. There are alternative explanations, such as a random rockfall or a local earthquake occurring within 1,000 years of the Meteor Crater impact that could have happened independently." Nonetheless, the meteorite impact, the significant landslide, the lake deposits, and the driftwood found high above river level are all rare and extraordinary events. The average of the dates from these findings converges into a narrow timeframe of 55,600 plus or minus 1,300 years ago, lending credibility to the hypothesis that they are causally linked. For further details, refer to the study titled Grand Canyon Landslide Dam and Paleolake Triggered by the Meteor Crater Impact at 56 Ka published in Geology, 2025. Citation: Study finds link between Grand Canyon landslide and meteor crater impact. 2025, July 15. Retrieved July 19, 2025 from https://physics.org/news/Grand-canyon-landslide-meteor.html. This document is protected by copyright. Except for fair use for private study or research, no part may be reproduced without written permission. The content is provided solely for informational purposes. 3. Did a meteor impact trigger a massive landslide in the Grand Canyon? Scientific investigation. Imagine a massive meteor crashing into the Earth's surface, triggering a landslide that alters the course of a mighty river and creates a lake that lasts for centuries. This is the fascinating story that scientists from the University of Arizona and the University of New Mexico have been unraveling, and it's a tale that could change our understanding of the Grand Canyon's history forever. But here's where it gets interesting: the meteor impact that created the famous Meteor crater in Arizona may have had a profound effect on the Grand Canyon, located hundreds of miles away. The connection between these two natural wonders has been hiding in plain sight, and researchers have been working tirelessly to piece together the evidence. The story begins with a mystery that has puzzled scientists for decades. How did driftwood and lake sediments end up in a cave called Stanton's Cave in Marble Canyon, 150 feet above the Colorado River? It's a question that has sparked a lot of debate, and one that requires a deep dive into the Earth's history. As we explore this intriguing topic, we'll delve into the world of geology, paleontology, and the science of meteor impacts. So, let's start with the basics. What do we know about the meteor impact that created Meteor crater? The impact occurred around 56,000 years ago, when a massive meteorite struck the Earth's surface, creating a crater over a mile wide and 550 feet deep. The impact would have released an enormous amount of energy, causing massive destruction and triggering powerful earthquakes. But could this impact have had a ripple effect, causing a landslide in the Grand Canyon that dammed the Colorado River and created a massive lake? This is the question that researchers have been trying to answer, and it's a topic that sparked a lot of controversy. On one hand, the evidence suggests that the meteor impact could have triggered a landslide, which in turn would have created a lake that lasted for centuries. On the other hand, some scientists argue that the connection between the meteor impact and the landslide is still speculative, and that more research is needed to confirm this theory. So, what's the evidence that supports this theory? For starters, researchers have found that the driftwood and lake sediments in Stanton's Cave date back to around 55,000 years ago, which is roughly the same time as the meteor impact. This suggests that the lake that formed in the Grand Canyon may have been created as a result of the landslide triggered by the meteor impact. Additionally, scientists have found that the rockfall dam that created the lake would have required a massive amount of energy to trigger, which is consistent with the idea that the meteor impact could have caused the landslide. But here's the thing: the exact path and altitude of the meteor are not known, which makes it difficult to determine the exact effects of the impact on the Grand Canyon. Nevertheless, researchers believe that the triple effect of the shock wave, blast wave, and impact could have been enough to shake loose portions of the canyon's steep cliffs, triggering a landslide that dammed the river and created a lake. As we consider this theory, we have to ask ourselves, what are the implications of this discovery? If the meteor impact did trigger a landslide that created a lake in the Grand Canyon, it would be a game-changer for our understanding of the Earth's history. It would suggest that meteor impacts can have far-reaching effects on the environment, and that the consequences of such an event can be felt for thousands of years. But this is also where it gets controversial. Some scientists might argue that the connection between the meteor impact and the landslide is still speculative, and that more research is needed to confirm this theory. Others might argue that the evidence is compelling, and that this discovery could have significant implications for our understanding of the Earth's history. So, what do you think? Do you believe that the meteor impact triggered a landslide that created a lake in the Grand Canyon? Or do you think that the evidence is still speculative, and that more research is needed to confirm this theory? Share your thoughts in the comments below, and let's continue the conversation. As we conclude this story, we're left with more questions than answers. But one thing is certain: the discovery of the potential link between the meteor impact and the landslide in the Grand Canyon is a fascinating topic that deserves further exploration. Whether or not you agree with the theory, it's undeniable that this discovery has sparked a new wave of interest in the science of meteor impacts and their effects on the environment. So, let's keep the conversation going and see where this fascinating topic takes us.